Ever wondered how crucial I/O modules are in industrial networking? These unsung heroes serve as the vital links between a CPU and a network, facilitating data transfer, managing power loads, and controlling machine functions. Imagine trying to orchestrate a symphony of manufacturing equipment without a conductor. That's what a network without I/O modules would look like. These modules enable system integrators to connect disparate devices, giving them greater control of the industrial network. This is especially beneficial when dealing with legacy machinery, devices and systems that may not natively communicate with the desired industrial protocol. Moreover, I/O modules help manufacturers extend their network to incorporate all manufacturing equipment. This not only provides increased control, but also enhances operational visibility. They tackle the challenge of collecting peripheral data, which can vary in volume, speed, and format. So in essence, without I/O modules, it would be impossible to achieve a truly connected factory environment. Now that we've established their importance, what exactly are I/O modules and what are their core functions? I/O modules, or input-output modules, act as the bridge between a CPU and a network. They facilitate the transfer of data, manage power loads, and control machine functions. They allow system integrators to connect a variety of devices, even those that are not natively compatible with a desired industrial protocol. For manufacturers, I/O modules extend their network to all manufacturing equipment, offering greater control and increased operational visibility. Let's delve deeper into the core functions of these critical components. Firstly, I/O modules are excellent at detecting errors. They do this by using methods like the parity bit to identify and report errors to the CPU. Secondly, they are instrumental in processor communication. This involves several tasks such as command decoding, data exchange, status reporting, and address decoding. Thirdly, these modules buffer data, managing the transfer speed of data sent by the processor to peripheral devices. This helps to balance the latency of peripheral devices. I/O modules also enable communication between connected peripheral devices. Lastly, they are tasked with control and timing, managing the data transactions between the internal system and peripheral devices. And let's not forget, I/O modules can also work as accessory devices for PLCs and HMIs. So, I/O modules are like the unsung heroes, facilitating communication and ensuring a smooth flow of data in an industrial network. Now let's delve deeper into the different types of I/O communication techniques. There are three primary methods to be aware of: programmed I/O, interrupt-driven I/O, and direct memory access, or DMA. Starting with programmed I/O, this technique requires the central processing unit, or CPU, to initiate a program for the transfer of data from an I/O device to memory. In this process, the CPU remains in a loop until the I/O device is ready to transfer data. It's like waiting for your turn at a coffee shop until the barista is ready to take your order. Next up, we have interrupt-driven I/O. In this scenario, the CPU gives a read command to the I/O device. When the I/O device is ready to transfer data, it sends an interrupt signal to the processor. This is like a friend tapping your shoulder when they're ready to speak. Upon receiving the interrupt, the CPU checks the device's status and, if ready, will write the information into memory. Last but not least, we have direct memory access, or DMA. This technique allows an I/O device to transfer data directly to or from memory, bypassing the CPU. Think of it as a VIP pass, allowing the device to skip the line and go straight to the memory. As you can see, each type of I/O communication technique contributes to the smooth operation of an industrial network, further emphasizing the importance of I/O modules.